Welcome to the deep dive. Today, we're cutting straight to the core of something really fundamental. What it means to be a professional engineer or geoscientist here in Canada.
Yeah, it's definitely more than just having the technical know-how.
Exactly. It's about this unique um, legal and ethical position they hold in society.
And compact, right?
Right? Because the work these professionals do, well, it impacts public safety, our environment, the economy,
Hmm.
pretty much every day.
The stakes are incredibly high.
Which is why the standard of care required is so foundational, baked into the Canadian legal structure itself.
Mm-hmm.
So our mission today, we're going to unpack this whole concept of skilled and regulated practice. It's really the absolute cornerstone of the NPPE blueprint, the National Professional Practice Exam.
And, for anyone trying to really get their head around the legal framework that grants this, well, the significant privilege, there's a key takeaway right from the start. Professional status in Canada isn't just about having a degree. To legally practice, to offer those professional services, you need three things, inseparable things. Technical competence, yes, but also this deep ethical responsibility and, crucially, a license granted under provincial law.
Competence, ethics, license. Got it.
You can't have one without the others, legally speaking.
Okay, let's dive into that first part then. Skilled practice. What does that actually imply in this professional world? It's clearly, like you said, broader than just acing your university courses.
Oh, absolutely. It has to be. Professional skill, as the sources define it, isn't static. It's this dynamic combination, really, of four key elements that you have to apply consistently, day in, day out.
Four elements.
Yeah. It's a blend of deep technical knowledge, sure, but also practical experience, sound analytical judgment, knowing how to apply the knowledge, and really important, unimpeachable integrity, without a doubt. So breaking it down, a professional has to show: 1, technical competence mastering the theory and the tools. 2, analytical judgment applying that knowledge responsibly. 3, ethical awareness understanding the wider impacts on society, the environment.
Okay.
And 4, a real commitment to continuous improvement, keeping those skills sharp.
If you fail on even one of those,
Well, it's not just that you're maybe not a great professional. It means you've potentially broken that legal trust, that compact we mentioned.
that distinction failure is a legal breach that's so vital for anyone taking the NPPE to understand.
Absolutely critical.
And speaking of trust, let's talk about the professional seal, that physical symbol.
Right, the seal, or the digital signature now, often. It's the ultimate visible mark of accountability.
So when you see that seal on a drawing or a report,
It tells the public, look, this work meets accepted professional and ethical standards. And just as importantly, the professional who put their seal here personally supervised it and takes full, unreserved legal responsibility for it.
wow, full responsibility.
It guarantees both competence and accountability were applied.
Okay, that sets up a really interesting historical question then. If competence is so obviously important, why did we need formal regulation? Why shift from skill being, a personal quality to something enforced by law?
That's probably the most critical historical context for understanding why regulation exists. In the early days of Canadian development, practice was, well, largely unregulated.
Right.
But as technology scaled up, especially in big infrastructure projects, the potential for failure grew dramatically. And when failures happened, they became catastrophes.
You're thinking of the Quebec Bridge.
Exactly. The Quebec Bridge collapses, plural. That's the defining example you'll find everywhere.
1907, and then again in 1916.
Yes, 2 collapses, almost a decade apart. That wasn't just a technical problem. It was a catastrophic failure of trust in the profession's ability to manage large, complex projects safely.
A massive blow.
Huge. Those disasters starkly showed that just relying on individual technical skill without standardized qualifications, without proper oversight, and crucially, without mandated ethical accountability, well, it would inevitably cost lives. That trauma, that public outcry, is what fundamentally pushed provincial governments to step in and create the legal acts that restrict practice.
That makes sense.
Yeah.
The risk was just too high.
Precisely.
Okay, just before we dig into the legal mechanics of all this, a quick note. If you are studying for the NPPE, or maybe you're just interested in understanding the bedrock laws that keep our infrastructure safe, you really should subscribe right now. We tailor these deep dives to give you exactly the kind of context and clarity you need for the NPPE content. So go ahead, hit that subscribe button. You won't want to miss what's coming up. All right, so that historical backdrop, the Quebec Bridge example, it leads us right into the unique legal framework we have today. Why is this profession regulated by the state, restricting who can practice? Unlike other complex jobs out there, maybe like management consulting or something, what's the specific need for state oversight here?
Well, it really boils down entirely to one thing: protecting the public. Public safety, environmental sustainability, and long-term economic stability.
The potential impact.
Exactly. When a professional engineer or geoscientist makes a significant error, the consequences aren't abstract. They can be immediate, devastating, potentially irreversible, affecting, thousands of lives, property, the environment.
The stakes are just different.
They are. And legally, what's fascinating is the concept behind it all. It's about the delegation of authority from the state.
Okay, what does that mean exactly?
It means the provincial legislatures, through the acts, grant the professional associations the right to govern their own members, essentially, on behalf of society.
So the government is trusting the profession to regulate itself.
Basically, yes. The government is saying, we trust you, the professionals, to police yourselves because you understand the complexities. But, and this is a huge but, we grant you this privilege, this license to operate and self-regulate only as long as you effectively protect the public interest.
And if they don't?
The government can take that privilege back. It's happened before in other sectors. So in return for this significant privilege of self-regulation, professionals have this overriding duty to uphold the public interest above everything else, above their employer's interests, above their own interests.
Public interest first. That's incredibly clear. And this delegation, it takes shape in the actual provincial laws, the Engineering and Geoscience Acts.
That's the legal backbone.
So these acts, they basically do three key things, right? They define the scope of practice, what constitutes engineering or geoscience work. They protect the titles PEE, PGO, PEE, so only licensed people can use them. And they set up the regulatory body, the association or order, to handle licensing and discipline. Is that the core structure?
That's it, exactly. Those three functions are mandated by the law in each province and territory. And this structure leads us directly to that unique Canadian model of self-regulation.
Where peers set the standards.
Right. Peers, other licensed, experienced professionals who actually understand the nuances and complexities of the work. They're the ones setting the standards for entry, for ethics, for practice, and crucially, for enforcing discipline when things go wrong.
What's the thinking behind that? Why not have government regulators do it?
The rationale is, fundamentally, that only those who practice the profession possess the deep technical and ethical understanding needed to fairly and accurately assess competence and conduct within that profession. An outside body might not grasp all the subtleties. But, and it's important to stress this, self-regulation isn't a right. It's a privilege that comes with immense responsibility. The profession constantly has to prove to the government and to the public that it can protect the public interest effectively. It needs fair, transparent processes for licensing, for complaints, for discipline. Otherwise, as we said, the government can step in and change the system, potentially removing that self-regulatory power.
Okay, let's zero in on the specific obligations this whole system puts on the individual professional. We know about the first one, the exclusive right to title and scope. Only licensed pros can do certain work or call themselves PE or PGO.
Correct. That's the gatekeeping function to protect the public.
But the second one, competence. I think this is where the NPPE really tests candidates. It's not just about being competent when you get licensed. It's an ongoing legal obligation.
That is such a critical point. Yes.
Yeah.
Once you're licensed, you are legally, ethically, and professionally required to maintain and enhance your skills throughout your entire career. That's where continuing professional development, or CPD, comes in.
It's not optional.
Absolutely not negotiable. Think about it. Technology races ahead, codes and standards evolve constantly, societal expectations change. Failing to keep current isn't just, falling behind. It can actually constitute professional negligence or incompetence under the Act.
Meaning you could face disciplinary action.
Severe disciplinary action, potentially including losing your license. Maintaining competence is a core legal duty.
And the third major obligation, ethical accountability. This is mandated through the provincial codes of ethics, right?
Exactly. And the cornerstone of every code of ethics across Canada is that paramountcy principle.
Hold paramount the safety, health, and welfare of the public.
Precisely. That single sentence transforms technical work into a form of public service. It legally requires that the public interest must always override the interests of a client, an employer, or even the professional's own personal gain or convenience.
That idea, the primacy of the public interest, that's often a really challenging concept for NPPE candidates, isn't it?
It is, because it can create real-world conflicts. But it's non-negotiable. It's the ethical foundation of the entire regulated system.
Okay, so that brings us neatly to the professional life cycle. How does the system actually ensure someone is ready to take on this huge responsibility? How is this blend of skill, legal understanding, and ethical commitment validated?
Well, it's a very structured, multi-stage path. It doesn't happen overnight.
Starts with education, I assume.
Yes, it typically starts with validated academic qualifications, usually an accredited engineering or geoscience degree. That provides the foundational technical knowledge.
That's just the start.
Just the beginning. Then comes several years, typically 4 or more, of supervised practical work experience. This is often called the engineer in training or geoscientist in training period.
And it's supervised by a licensed professional.
Critically, yes. Under a licensed PEM or PGO. This isn't just about learning the technical ropes, it's mentorship. The supervisor is responsible for guiding the trainee on applying knowledge ethically, understanding the regulations, learning professional judgment, and importantly, understanding what it means to take responsibility for work.
So it's technical and professional development.
Both, hand in hand.
And that whole period leads up to the NPPE, the professional practice exam. Now, we often hear candidates stressing about technical exams, but the NPPE is different. It focuses heavily on ethics, law, professionalism. Why that focus?
Because the NPPE serves as the final gatekeeper, specifically for the professional aspects. The technical competence is largely assessed through the degree and the supervised experience. The NPPE specifically tests whether the candidate understands the legal framework, the ethical obligations, the concept of professionalism, the disciplinary processes, basically the rules of the road for practicing safely and responsibly in Canada.
So passing it confirms you're ready to use your technical skills within that regulated ethical system.
Exactly. It confirms you understand the weight of the responsibility you're about to formally accept. Without that demonstrated understanding, frankly, the technical skill alone could be seen as more of a risk than an asset to the public.
Right. And once they clear that gate, pass the NPPE, meet all requirements, then they earn the right to use the title and the seal.
Correct. And that seal, as we discussed, becomes that visible symbol, the link between the validated skill, the regulation, and the public's trust. It signifies personal accountability.
And that accountability, that need to prioritize the public, requires something more, doesn't it? You mentioned integrity earlier.
It requires ethical courage. That's a term often used.
Ethical courage.
Yeah. Skilled practice isn't just about calculations and designs. It's about having the foresight to anticipate potential social and environmental consequences of your work. It's about having the humility to recognize the limits of your own competence and knowing when to say, I don't know, or we need another expert.
And acting on that.
And crucially, acting courageously when public safety might be compromised. Even if it means pushing back against an employer or a client or facing uncomfortable situations, that's where the Code of Ethics provides the backing.
That ethical courage, though, must be constantly tested in today's world. The landscape seems more complex than ever. What challenges are really putting pressure on this balance of skill, regulation, and ethics right now?
Oh, there are several significant forces at play. It's a dynamic environment. First, you've got the sheer pace of technological change. It's relentless.
AI, new materials.
Exactly. Artificial intelligence, advanced materials, big data analytics, automation. Professionals have to engage in constant, serious, continuous learning, that CPD we talked about, just to maintain baseline competence in their area. If you fall behind, you're potentially putting the public at risk.
So CPD isn't just box ticking.
Not at all. It's essential risk management for the public. Second, there's corporate and sometimes political pressure. This is a huge one.
How so?
Well, many professionals work for companies whose primary driver, understandably, might be profit or meeting tight deadlines. That can create an inherent tension with the professional's paramount duty to public safety.
A potential conflict of interest.
A direct conflict. And the regulatory structure, especially the Code of Ethics, is designed to be the professional's shield in those situations. It gives them the legal and ethical grounds to say, no, we cannot cut that corner, or no, this design isn't safe under these constraints, even if it impacts the bottom line or the schedule.
So the code isn't just guidelines, it's their legal duty to refuse unsafe directions.
It's their mandated duty. They must resist pressure that compromises professional standards or endangers the public. Third challenge, globalization.
Right, projects crossing borders.
Exactly. It complicates things. If a Canadian PM is working on a project overseas or an international engineer is contributing to a Canadian project whose rules apply, How is accountability ensured across jurisdictions? It requires careful navigation of different legal and ethical landscapes.
And finally,
Public scrutiny. We live in an age of instant information, social media. The public, quite rightly, demands greater transparency and accountability from all professions, especially those with such a direct impact on safety. This puts enormous pressure on the association's disciplinary processes to be robust, fair, and seen to be effective.
so staying professional in this climate takes more than just technical skill.
It takes incredible resilience, sound judgment under pressure, and an unwavering commitment to those ethical principles.
This has been incredibly clarifying, a real deep dive into the foundations. So to wrap up for our listeners, especially those prepping for the NPPE, if they could really grasp these four pillars we've discussed, competence, ethics, legal authority, and accountability, they essentially got the core of what skilled and regulated practice is all about.
I believe they absolutely have. Those four pillars are the bedrock. Competence verified through education, experience, and that crucial lifelong learning. Ethical responsibility driven by the codes of ethics and that paramountcy duty. Legal authority granted by the provincial acts defining scope and title. And finally, accountability demonstrated through the professional seal, the acceptance of responsibility, and the disciplinary mechanisms of self-regulation.
Competence, ethics, authority, accountability.
Master those concepts and you understand the essence of being a regulated professional in Canada.
Fantastic.
And maybe here's a final thought, something for you, the listener, to mull over. We know there are international agreements, like the Washington Accord, that recognize engineering degrees across many countries. This facilitates mobility.
Right, makes it easier for engineers to work internationally.
It does. But, and this is key, these agreements recognize educational equivalency. They do not remove the obligation for an engineer or geoscientist, no matter how experienced or where they're from, to register with the local provincial or territorial association before they practice in that specific jurisdiction.
So even with global agreements, the license to practice is still local.
It's fundamentally local because the legal authority, that delegation of trust from the state we talked about, is granted province by province, territory by territory. What does this continuing local legal accountability mean for the future shape of global professional practice? Especially as projects become more international, it's something worth considering.
That's a great point, highlighting that local accountability remains paramount despite globalization. A perfect place to end our discussion. If you found this deep dive helpful for understanding the regulatory world of engineering and geoscience in Canada, and especially if you're gearing up for the NPPE, please do subscribe right now. That way, you won't miss future deep dives designed to help you understand the material and ultimately be successful in that exam. Thanks for joining us.